Hello, Calc. We just have maybe 4 videos left, so I think I might just go ahead and make them. And you can self-pace through the videos and the work. And whenever you get to the end, we'll be practicing our AP test. If you're not taking the test, your final will be very AP-ish. It'll be problems from past AP. And so it'd be very good to pull everything together with a lot of practice. So when we finish these 4 videos, say, we're all set to go into AP practice. So let's see what's on our plate for today. We've been taking volumes. I don't know what date we're going to be at when you're watching this. I just put Friday's date, taking a guesstimate. So the date you're watching it is the date you're watching it. Many cases in real life can be described by differential equations. And these are equations with derivatives in them. So a derivative can be written as y prime or dy dx. I think I prefer when possible. In some cases not so, but definitely in this case I prefer dy dx equals 2x plus y. This is an example of a differential equation. There's a derivative in the middle of the equation. Did my equal sign show up? Okay. So now dy dx equals 2x plus y. So the answer to an equation in the past would be something like x equals 4, something like that. But now our answer is not going to be a value like that. It's going to be a function or an expression. So what this is saying, what expression, y is an expression in x, when you take the derivative of it, you get 2x plus y. So the answer again is a function or an expression. But before we actually work on solving these, you see I haven't titled it differential equations. We're going to actually picture this before we go ahead and I teach you how to solve a differential equation. Sorry about that. So let me teach you that. When we picture the answer to this differential equation, we have to create what's called a slope field. And that's our lesson for today. I think I only need to do one for you. And a slope field is going to be drawn on the x-axis and xy plane. So you want a very large one where maybe you have 1, 2, 3 with quite a bit of space on your page. You don't want to squish it up. And so spread out if you can. Some of you have trouble doing that, but you will be glad on slope fields. So, ever play the game of dots? Maybe we played it as a review once. Well, I'm going to put a dot in for every point on the graph, such as 1, 1, 2, 1, 2, 2, 3, 2. And I may not get the slope field built around all these dots, but I'll at least get to a point where you would be able to finish the slope field. A true slope field can be any size, but this will give us a pretty good picture of what is happening. So the way we do a slope field, and I won't write out a chart, I can do this a lot easier in my mind, and so can you, but for training purposes, I need to pick an x and y, and then calculate dy dx, and then sketch that on the graph. So, for example, let's pick this point right here. At this point, x is 1, right here. I went over 1, up 1. X is 1, y is 1. So looking at the equation, I can find out what dy dx is. 2 times 1 plus 1 will give me 2 times 1 plus 1 will give me 3. So at this point, I have to draw a tiny portion of this curve, and it has a slope of 3. So 3 is a very, like here is 1, slope of 1, slope of 2. So slope of 3 is a very steep slope. It's not quite straight up and down. And notice I just draw a little section of it right at 1, 1. All right, let's try 0, 0. 2 times 0 plus 0 is 0. So here the derivative dy dx is 0. So that means it's flat. So it's my sketch right there. And let's try, say, this point, negative 1, 1. So I went back 1, negative 1, up 1. 2 times negative 1 is negative 2, plus 1 is negative 1. So at this point, I'm going to draw a negative slope of 1, like that. All right, so you'd say, wow, it'd take quite a while to do all of these points and get this slope field. However, let me show you some tricks of our trade so it can kind of help us go quickly through the slope field sketch. So say I'm at here and I see 0, 0 gave me 0. How about if I just go up and down rather quickly, maybe not taking the time to go over here, but doing it mentally. So this point is 0, 1. 0, 2 times 0 plus 1 gives me 1. And if I go up to here, 0, 2. 2 times 0 plus 2. It's more of a slope, and then plus 3. So I got those, once I got the first one, I could get the others rather quickly. Let's go down now from there. Say this is 0 minus 1. 2 times 0 minus 1 gives me a slope of negative 1. And then this one would give me negative 2. And this one negative 3. So not very clear. We're not exactly clear where the slope of negative 2 is, but we know negative 1 would be cutting in this angle, so 2 would be like this, and 3 would be even steeper. All right, so now I'll do the same things. It's easier to do it going across or up and down, so you can get them more quickly. So let's go to over here. 1, 1 we already did. Let's do 1, 2. 1, 2 times 1 plus 2 is 4. So we have a very steep slope here. And up here it's just going to be 1, 3. So it's going to be 5. So it's almost vertical. So, and then coming back down on that same one, we have 1, 0. So 1 and 0 gives us a 2. Let's go down to here. That's 1, negative 1. 1, negative 1 will give us negative 1. And what will this one give you? 1, negative 2, give us 0. And then here, 1, negative 3 will give us negative 1. So I'll head over here and I get 2, 0, 4, very slopey. Here it's going to be more and more of a slope. Going down, 2 minus 1, 4 minus 1 is 3. And down here, 2 minus 2, 4 minus 2 is minus 2? No, I think I did that wrong. 2 minus 2. 4 and a minus 2 is 2. And then we have, this one is 2 minus 3, 4, so that's a 1. 1, 2, 3. All right, so let's hop over here, 3, 0. 6, a very, very high slope. and it even gets higher as we go up, and as we go down this becomes 3 minus 1, so it'll have less slope, less slope, less slope. Alright, so I'm going to finish this slope field silently, and you can go ahead and try to match what I'm getting. Alright, so that's a rough sketch of the slope field. Now, this slope field is, remember, lots of functions will satisfy this because of the plus C situation. So sometimes we're asked to find a particular solution. So I'll show you what that means. Suppose we want the particular solution. That's one solution through. So I want the particular solution through 1, 1. So looking at that, I'm going to start with my pencil at 1, 1, and I'm going to draw a curve that has a slope that matches that. And then it's going to go up and hit this one and be even slopier. Alright, and then here it hits a flat area, and then it goes up like that. So that's an idea of what this slope, actually this slope, it looks like I bent a little too far that way. So I've got to obey the slope that I'm on until I hit the next slope section. So this one was like this until it hit in here where it curved up. So it's a little more curving up there. So this is a particular solution for this differential equation. So slope fields will entertain us and challenge us on our next assignment. Till then, class, carry on.